Today in this video, I am going to show you the working of this 4x4 matrix keypad with the help of this simple circuit using push buttons and 8 number of LEDs. And in the last of the video, I will show you the interfacing of the LCD display with Arduino. So the keys inside the keypad simply act as a push button, and you can see one terminal of the button in a particular row are connected to each other, right? And the other terminal are connected to each other in a particular column. So suppose if I press key number 1, the connection will be like this. The row 1 will be connected to column number 1, right? Suppose if I press this push button, the row number 2 will be connected to column number 3. So this will be the connection. Now the connections of the circuit is something like this. One terminal of the push button is connected to the negative rail of the breadboard, and other terminal is connected to the cathode of the LED. Let me show you by removing it. So you can see this is the cathode end and this is the anode. So anode is connected to the positive rail and cathode is connected to the other end of the push button. And similarly here, all these LEDs are connected to the positive rail, that means anode is connected to the positive rail and cathode is connected to the resistors. Now what I am going to do, I will connect the row pins starting from 1, 2, 3, 4 to these push buttons, right? R1, R2, R3, R4. And the column pins will be connected to these resistors, C1, C2, C3, C4. Now see, these push buttons are connected to the row pins and these resistors are connected to the column pins. Now how does your microcontroller know which button you pressed on the keypad? So what it does basically, it performs row scanning and column scanning. Scanning simply means sending a voltage signal on a particular row or a particular column, right? Now the standard keypad library performs scanning of the row number 1 first. Then it checks column number 1, then column number 2, then 3, then 4. After scanning row number 1, then it goes to row number 2. Again it checks column 1, column 2, column 3 and column 4, and it repeats this process for row number 3 and row number 4 as well. So this process of scanning all rows and all columns happens 1000 times a second, and this is just a simple demonstration to mimic the scanning of rows and columns. Now I am providing external 5V supply here at these two terminals. Now let's run the demonstration. So this push button corresponds to row 1, this is for row 2, this is row 3 and this is row 4. And if I press this push button, what will happen? This purple terminal and the cathode of this LED will be grounded, and because of which the entire row 1 will be grounded, right? And if I press any key in this row number 1, the corresponding green LED will turn on. Like if I press number 1, the first green LED will turn on. For row 2, sorry, the key number 2, the second LED will turn on. Similarly for all the keys, right? But if I press any key except in the row 1, the LEDs won't turn on because only the row 1 is grounded, right? Similarly, if I press this push button, the number 2, the row 2 will be grounded. And if I press the push button in this row 2, the keys will start to turn on. So in this way, the microcontroller sends the voltage signal on the particular row and it scans each column one by one. Okay. Now you can also do the column scanning first and row scanning later on. So for that, just you need to connect the column pins at these push buttons and rows pins on these green LEDs. It means just connect these 4 wires on the green LEDs and these 4 wires on the red LEDs. Just swap the positions. So you can see I have swapped the positions of the wire, and if I press this first push button, the column 1 will be grounded. And if I press any key in this column number 1, the corresponding LED will turn on. So I have interfaced the LCD screen, keypad and the Arduino with each other, and whatever key I will press on the keypad, that is going to display on the LCD. So suppose I press the hash key, so it has been displayed. Similarly star key, key number 4, key number 6, key number 2. So for the LCD display, I am using the I2C module here, which has 2 wires, SCL and SDA for the communication. So I have dedicated pins for the SCL and SDA on the Arduino Uno. If you don't have those, you can safely connect the SCL pin to A5 and SDA pin to A4. So if you enjoyed this video, don't forget to like, share and subscribe, and tell me in the comment section what next project you want to build using this keypad. And thanks for watching this video.